All right, so we are now going to do the density of a liquid. Density of a liquid. Now, unlike density of a solid, density of a liquid has the whole thing on the scale and the cylinder at the same time. For the solids, they were separate. For the liquids, we're going to do them both. Now, we turn on the balance like we did before, making sure that it comes to 0.00 or 0.0, depending on what balance you have. I lift up the lid. If it changes, no big deal, just let it resettle. Now, unlike with the solid, with the liquid, you're going to put the cylinder directly onto the balance. Now, I have my cylinder here, and as you can see, there are droplets of water in it. To reduce error, I'm going to take a paper towel, I'm going to rip it in half, long ways, and I'm going to crunch it up, and I'm going to clean out my cylinder. This way, I reduce my error. See if you can get it all the way down there. If you cannot get it all the way down there, then that is an error statement. Look, I did get it all the way down there. And so then sit there and just rotate it a bit. You have to scrub the insides of that cylinder and then wipe down the outside so it's not slippery. Now you want to be careful with the cylinders because they can fall and break. We want to reduce that. So I'm reducing error. Now I put it on the balance and I zero it because I want the balance to ignore the weight of the cylinder. I want it just to get the weight of my chemicals. Okay, I'm going to be adding this mystery blue liquid to it. Now again, like we did with the solids, we're going to want to tilt and add. Now, since density does not matter to sample size, but graphing it does, I recommend having an even pattern. I'm going to do 3, 6, and 9. So I'm going to add about 3 milliliters, about 6 milliliters, about 9 milliliters. I'm not going to go for exact. I'm just going to do approximates here. I'm going to get my paper so I can record it. So again, I tilt, make sure I can read it, and I add. I minimize the splashes and spills. Spilled some on that paper. That happens. Okay, so there we go. I now have about 3, as you can see here. There you go. All right, we want to hold it up to eye level. And, and never hold it up with your hands. Put it on a flat surface. Bring yourself down to the level or up if you have a shelf. This is 3.12, 3.19. So for my first one, I have 3.19. Now I did spill a drop of the mystery chemical on what I was going to write on. We're just going to throw that out carefully. We're actually going to let the teacher know. The teacher says, which is me, says it's okay to throw it out, so I'm just going to throw it out. So my first measurement, I've got volume, I've got mass, and I've got density. The nice thing about doing the liquids is you're only going to have volume, mass, and density. You're not going to have that volume of water, volume of metal, and water. Just 3 things: volume, mass, density. Done. All right, so my first volume, as I said, was 3.19 milliliters. So 3.19 mLs. My mass, I read it right off the scale, right there. It's right there. It gives it to me both. 3.0 or 3.08 grams. So there we go. There's my first measure. Now, with solids, you had to dry it off and restart each time. For liquids, you don't need to do that. You can just keep going. So I'm going to take it off of the scale. I am not going to zero the scale. I'm then going to add about 3 more to it. I want to do it at an angle. Oh no, I poured way too much in. Oh, that was only somewhat deliberate. As you can see there, I got significantly over the 6, but that's okay. Because remember, density really doesn't matter as to what you do. So now I'm going to take this and read it at eye level. So I'm going to place it, lower myself down to eye level, and get a good read. 6.5, 6.6, 6.67, because we want to read the bottomiest bottom, because that's where the meniscus goes. 6.67. Oh, what did I say, 5? Oh, I forgot, gotta do it again. That's why having a lab partner is really good. They will typically remember 6.67, 6.67, okay. So, then the scale says 6.57, and that would be in grams. And then I do my third. Now be careful, you do not want to pour this over the 10 line. You'll have to reset, you'll have to restart, throw that data out. So you want to be careful here, all right? So you want to get it, since I decided on 3, 6, and 9, I want to make sure I get it to the 9. Now, I did not quite get it to the 9, as you can kind of see there, but again, that's okay. I'm going to put it, lower myself down to eye level. 8.5, 8.6, 8.73. 8.73 milliliters. 8.73 mLs. And the weight is 8.61 grams. Now, that said and done, I do notice that there's some error. If you look carefully, you'll see that there are droplets of the unknown liquid sticking to the cylinder. Right there at the top, right there down there. That's an error. Now, since those droplets are there, they will not increase volume. They will increase mass, which means density goes up. This is the sort of thinking you want to do when you have an error. Now, being that there are not that many droplets, this would probably be a minor error, meaning not a huge, huge deal, but still need to record it and have it down. You'll also notice the scale occasionally shifts. That is because the scales tend to be very sensitive. Whatever number sticks around the longest is the number you record. And that's that. When you are done, talk to the teacher about disposal. These chemicals are just going to go back into the container that I got them at. So that way I can use them again and again, as these ones are not volatile. So there you go. That is how you do density of a liquid. I know I did not calculate the densities here. I can do that later. That's again just mass divided by volume. And then you're going to get the average. You're going to take all 3 of them, add them together, and because there's 1, 2, 3 data points, divide it by 3. So that is our whole getting density via a liquid.